Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of some important questions of kinematics of variable acceleration. For this lecture, I am using the work of one of my best student, Miss Fatima Shah of class 2022, the Lyceum. An important advice for me and for everyone, we must be well mannered. This is question number 1. A particle P starts from rest. Rest means u0 at the point A from this point at t0. So at this point t0 and u0, and moves in a straight line with constant acceleration a for 10 seconds. This is very important. Constant acceleration means we can use equations of motion for this from these 2 points for this interval 0 to 10. For this interval, for the next 10 seconds, P continues to move along the line with velocity. This is the variable acceleration. So motion from A to B at B time is 10. Motion from A to B acceleration is constant, and motion from B to C acceleration is variable. So here we will use equations of motion, and here we will use calculus. And this is the common point. At this point or at t10, we will get same velocity with the help of this equation and this information. So we will use this equation to get this velocity at t10. At t10, velocity is 6. Now the first part, find the speed of P at t10. It's 6, and the value of A. For value of A, we will use equation of motion from A to B. So according to this equation of motion, we have acceleration 0.6. Here V is 6, U is 0, and T is 10. Part 2. We need value of T for which acceleration of P is negative A. For that, we need to use this equation. We need to differentiate it. When we will differentiate this equation, we will get equation of acceleration, which is minus 1600 upon t cube. And we just need to substitute minus a here. The value of a is 0.6, so value of minus a is minus 0.6. And when we will solve this, we'll get the value of t. It's 13.9 seconds. Next part. We need the displacement of P from A when t is 20. Make sure you use the correct formula and right thing for both the motions. Like you need to use equation of motion for motion from A to B or for motion till 10 seconds. And for this motion T10 to T20, you should use calculus. Because this is variable acceleration. For variable acceleration we use calculus, and for constant acceleration we use equations of motion. So we will get this displacement with the help of equations of motion. Any equation of motion we can use it here, and for this displacement we will use calculus. We will differentiate velocity t10 to t20. So we will get displacement in this way. Total displacement is displacement AB and then displacement BC. This is constant acceleration, so use equation of motion. And for this use calculus. This is here. I'm sorry. So t0 to t10 acceleration is constant, so find distance with the help of any equation of motion. So with the help of this equation, we have got the displacement 30 meter. From t10 to t20, we will use calculus because of variable acceleration. So time is 10 and 20. dt. This is 10 and 20. When you will integrate this thing, you'll get this thing. And when you will apply limits, you'll get this displacement, 20 meters. You can check this again. See, the first displacement A to B is 30 meters, and when you will solve this equation, you will get 20 meters. Therefore, total displacement is 50 meters. You can take the screenshot of this solution if you want. This is first page, and this is the next page. Second page. I'm sorry. Next question, number 2. A motorcyclist starts from rest at A, so it's U0, and travels in a straight line. For the first part of the motion, the motorcyclist's displacement from A, t second, is given by the equation. So this point is A, and here t is 0, V0 because rest, and displacement is also 0 because when you will put t0 here, you will get 0. Show that the motorcyclist's acceleration is 0 when t is 50. For that, you need to differentiate this equation twice. So when you will differentiate this equation twice, you will get the equation of acceleration. And when you will substitute 50 here, you will get 0. And now find the speed of v at this instant or time. So you just need to put 50 into equation of velocity. So first differentiate this twice and get the equation of acceleration, and then substitute 50 here, and you can easily show that acceleration is 0, and then substitute 50 here for the value of velocity. So velocity is 30 at t50. Let's suppose this point is B and this point is C. For t greater or equal to 50, the motorcyclist travels at constant speed. That means from this motion, from t50 onwards, the velocity of motorcyclist is fixed, which is v. So from t greater or equal to 50, we can use equations of motion. And for t till 50, from 0 to 50, we have to use calculus. Now, find the value of t for which the motorcyclist's average speed is 27.5. You all know the formula of average speed. It's total distance over total time. So average speed is 27.5. Total distance means distance AB, like distance till t50. You can say S1. And this distance. You can get this distance from equation of motion, and this distance from this equation. And total time means t50 and then this duration. So this duration is t minus 50, because at here t is time is unknown t, this is the final time, and this is 50, so this interval is t minus 50. This is here. This is the formula of average speed. So for t for t from 0 to 50, you can use equation of displacement which was given in the question. And for the next distance, this distance, you should use this equation, s is equal to v into t. So v is constant, which is 30, and time is t minus 50. So this is the second displacement, and this is the first displacement, and you can get first displacement with the help of this equation. So this is till t50, and this is t greater equal to 50, and total time 50 for this displacement, and for t is great, for this t minus 50 time is, this is t and this is 50, so this duration is t minus 50. This is here. When you will solve this equation, you will get time, which is 200, when the average velocity is 27.5. You can check the solution again, and you can take the screenshot of the solution if you want. Next question. Number 4. A vehicle is moving in a straight line. The velocity at time t seconds after vehicle starts is given by these two equations. So from t0 to 15 inclusive, we will use this equation, and from t greater equal to 15 we will use this equation. But one very important thing, 15 is inclusive in both the equations. So at t15 we will get same velocity from both the equation. So at t15 both velocities are same. v1 is equal to v2. Sorry. The distance traveled by the vehicle between t0 and t15 is 2 to 5. t15, therefore we will use this equation. We just need to integrate this equation from 0 to 15, and we need to equate this to 2 to 5, and we will get the value of a, which is 4. Now at t15 both velocities are same, so use this equation at t15. Substitute t15 here and here. So when you will use both this equation, you will get the value of p, which is 3375. Now the next part, we have done the first part. We had to find a and we had to show b. We have done both the things. Find an expression in terms of t for the total distance traveled by the vehicle when t is greater or equal to 15. So this is very simple. You have to use this equation. We have this distance. We just need to use this equation for the equation of displacement for this interval. And the formula is S is displacement till 15, like S1 plus S2. Like first displacement is 2 to 5, and the next displacement t greater or equal to 15, you should use this equation, velocity equation. Since we don't have interval, we don't have this interval like this 15 till 20, so we cannot use integration with limits. We have to use this concept, S is equal to v dt. Just use this concept. So when you will use this concept, S is equal to v dt, then you will get this equation. And for C, use this information, because at t15 we have displacement 2 to 5. Whenever we have two equations like piecewise equations, then always use this value of t and displacement, which is given 2 to 5 at this value of t, for the value of C. This is very important. So at t15 displacement is 2 to 5, so C is 450, and this is the equation of the displacement. We cannot use integration with limits, I told you, because we don't have complete sets of values of t. What if we had this value of t here, 15 till 20, then we could use integration with limits, and for that you had to use this thing. First displacement, which is 2 to 5, and next displacement 15 to 20. In this way you will get the equation directly. But you can only use this concept when you have these types of values of t. But when we have these types of values of t, then we cannot use this thing, definite integration. So for that we just need to use this and do the regular things like just use this and get the value of c and then substitute it into equation. So this is the way to get the equation of displacement when the value of t is like this. Now the next part, find the speed of the vehicle when it has traveled a total distance of 315. Since this distance is greater than 225, so you have to use this new equation of displacement. You cannot use equation of displacement of this part because displacement is greater than 225, and this equation will give you displacement till 225. So use this new equation. Substitute 315 here and get the value of t, and then substitute this value of t into right equation of velocity, the second equation of velocity, because time is greater than 15. You can check this solution again. This question is very simple. First you just need to use this equation, and displacement is given 225, and get the value of a. At this time both equations will give you same velocity, so just equate both the velocities at t15 and get the value of b. For the displacement, use this equation and get the equation of displacement, and for the last part use this equation and get the value of t, and use second equation of velocity and get the value of velocity. Next question, a particle starts at a point O and moves along a straight line. Its velocity t seconds after leaving O is this. Find the displacement of the particle from O when its acceleration is 0.6. So you have to differentiate this velocity first to get the value of equation of acceleration. This is the equation of the acceleration. Now use 0.6 here and get the value of t. So when acceleration is 0.6, time is 2.5. Now use this equation to get the equation of displacement from 0 to 2.5. So this will give you displacement. This question is very simple. We had equation of velocity, we had acceleration, and we need displacement at this instant, or displacement till this value of t. So first differentiate v and get the equation of acceleration, then use acceleration 0.6 and get the value of t, and then integrate velocity from 0 to 2.5 for the displacement. Next question. This is the last question of this lecture. A walker travels along a straight road passing through the points A and B on the road with speeds 0.9 and 1.3. So let's suppose this is the sketch of this motion. Although sketch is not required, but I'm just making it for your conceptual clarity. So the initial velocity is 0.9 and its final velocity is 1.3. This is 1.3 and this is 0.9. So a walker travels along a straight road passing through the points A and B on the road with the speeds 0.9 and 1.3. 0.9 and 1.3. The walker's acceleration between A and B, this point is A and this point is B, is constant and equal to 0.004. Now with the help of equation of motion, we can easily get this time and this displacement. And we need both time and distance. So time is 100 and displacement is 110. Now the next part. A cyclist leaves A, same point, same instant as the walker. She starts from rest, so from this point, and travels along this straight road passing through B at the same instant. Same instant means at t100 as the walker. At time t seconds after leaving A, the cyclist's speed is kt cube, where k is constant. So this motion is graph. If k is positive, then graph would be like this. Show that when t is 64.05, the speed of the walker and the speed of the cyclist are the same. Number one, we have to find the value of k. And we can easily find it with the help of this information. At t100, displacement of both the walker and cyclist will be same, 110. So we will use this information and we'll get the value of k. See, when we will integrate v, we'll get this equation. And when we will substitute t0 and s0, we will get c0. So this is the equation of displacement. Now we just need to put this thing S110 at t100 into this equation. This is the equation of the displacement, kt power 4/4. When we will substitute these two things into this equation, we will get the value of k. Now the next part is, show that when t is 64.05, the speed of both will be same. So we just need to put 4.05 into this equation first. So speed is 1.156. This is the speed of cyclist. Now we need the speed of walker. Let's suppose this is 64.05. So we can use equation of motion and we can check the speed of walker. So for walker, use this equation and check the speed. Both have same speed at t 64.05 shown. Now the next part. Since k is positive, so the graph of cyclist would be like this. It should be a curve. It should be like this because it's positive cube. So this is for cyclist and this is for walker. Now we need cyclist acceleration when at the instant where she passes through B at B times 100. So we just need to differentiate velocity for that. So when you differentiate velocity, you'll get acceleration. And you just need to put 100 here and the value of k here. So the acceleration is 0.132. So this is all. I hope this lecture will help you to understand how to solve the questions of kinematics of variable acceleration. You can take the screenshot of this solution if you want. And you must know how to sketch the velocity time graph of these types of questions. I'm not discussing this question, I'm leaving these questions because of the lack of time, short of time in fact. An important advice, we must be good to others. And good luck to everyone, and I'm extremely thankful to Ms. Fatma Shah who helped me to make this lecture. May Allah Pak bless her with great success. Ameen. Allah Hafiz.